Welcome back. Today we are going to go through lesson 4.2, which is about graphing quadratics from vertex form. So let's remind ourselves what vertex form is. When we write a quadratic function in vertex form, it looks like a times x minus h squared plus k. So we're going to use that form to graph some parabolas. There's two different methods we can use to do this, so you can pick which one works best for you. Method one is to plot the vertex. This is written in vertex form for a reason. It helps us to easily identify the vertex, and then we can plot some points around it. So in vertex form, your vertex is those h and k values. So if we look over here, we have our h value and we have our k value. So in this situation, in our example up here of 2 times x plus 4 squared minus 6, the h value is negative 4. Remember that in the original vertex form equation that we wrote up here, there is a minus sign here. So if we have a plus 4, that's really minus a negative 4, which means h is negative 4. The k value is the positive one, so this one would be negative 6 because it's a minus 6 at the end. So whatever's in those parentheses is really the opposite of what it looks like. So I would plot that vertex at negative 4, negative 6 by making a point down there. And then I would find and plot two other points that are around that vertex. So I'm always going to pick x values that are close to that vertex. So let's do negative 3. So if I plug negative 3 in, I get out a negative 4. And that tells me that I have a point at negative 3, negative 4. So I could plot that over on my graph as well, negative 3, negative 4. Remember that every parabola that we graph is symmetric around that vertex. So if I have a point at negative 3, 4, I can also reflect that to the other side of the vertex and get an extra point that way to help me. Let's do one more. So I'm going to plot negative 2 now. So going one more out from that vertex. When I plug in a negative 2, I get out a positive 2. So that means I have a point at negative 2, positive 2 on my graph. So if I go plot that, and again, I can reflect that over that axis of symmetry and vertex and get another point out there. So those reflected points that I just got, from negative 3, negative 4, when I reflected that over, I got negative 5, negative 4. And then when I reflected negative 2, positive 2 over that axis of symmetry, I got negative 6, 2. And then we can make that smooth parabola curve from those points. So that is one way to plot the vertex from vertex form and then find some other points around it by plugging values in and reflecting them over the axis of symmetry. The other method that we can use is using transformations. So when we start with a very basic no transformations graph, we know that the graph of it is centered at 0, 0 and goes up from there. So we can use our transformations to help us. So we're going to plot this example up here. And the order we're going to go in is to start with the horizontal translation. So remember, the horizontal translation is inside the parentheses. So in this case, that means it's going to the right 1. So the parabola from the parent function would shift right 1. So now it would be centered 1, 0. Then I would look at the a value for that stretch or compression. So this one has a 3 out in front. So that means the function is being multiplied by 3. So still centered at that same value, but now it's being stretched by 3. So it's becoming skinnier. Then if there's a reflection, I would do that. So that negative out in front is a reflection. So now it's centered at that same point, but still, instead of going up, it's going downward, staying that same skinnier shape. And then lastly, we do any vertical translation. So we look at that end one. This one is going up one. So from that graph we had, we shift everything up one. So it would look like that. So that is what transformations look like. Now let's take a moment and let's review all of our transformations that we have for quadratics. When we look at that parent function again up here, we know that the parabola is that U-shaped graph centered at 0, 0 and going upward. So each part of our vertex form equation is going to give us some values that help us determine where the parabola is going to land up. So the first thing we have is translations. Translations can either happen vertically because of this plus or minus k on the outside, or they can happen horizontally because of the plus or minus h inside the parentheses with the x. So remember, a vertical shift, when it is going upward, it would look like a plus 3 in this case because it's going up 3, but it would be a plus value. So that means that it would shift up here to 3 and be a parabola that opens up from there. If it's shifting downward, that would be an x squared minus 6. So coming down here and opening up from there. If it's a horizontal translation, so in this case we want to go left 5, remember that is an x minus negative 5 squared. So we would write that often as x plus 5. So it looks opposite of what it seems like it should be. So if I go left 5, that's going to come over here and be centered at negative 5. If I want to go right, then I would have x minus positive 2 squared. And that means that it's now centered at positive 2. So I have translations up, down, left, and right. I can also have what are called dilations. So we have a stretch or we have a compression vertically. So if we stretch it vertically, that means we're multiplying by a number outside bigger than 1. So if I want to factor a stretch in by 2, I would write the function 2x squared. And that means that my graph would be centered at the same spot, would be much skinnier, stretched vertically. Opposite of that is a compression, and that is where we shrink the graph kind of, so make it shorter. So if I have a compression by a factor of 1/4, it's going to be a number between 0 and 1, a fraction less than 1. So that would look like 1/4 x squared. And that means that it is going to get wider. So it means it's not going up as fast. Lastly, we can have reflections. We can reflect over the x-axis. So that's where it's multiplied by a negative out in front. So that would just be a negative x squared. And that is that parabola we've looked at a little bit before, which is drifting downward. I can also have a reflection over the y-axis, which is where the x values switch. So it's negative x in parentheses squared. Now, when we reflect a parabola over the y-axis, it doesn't really look any different on the parent function because it's symmetric. So it's not going to change the look as much. Okay. So the directions say to identify the vertex and then find at least 2 other points to make this. So in my vertex form here, I can see that I have a vertex at 4. So I'm going to label that as vertex out here, V for vertex. And there's nothing after the equation. There's no k value. So that means that the vertex is at 4, 0. So I can plot that on my graph. And then I can find some points around it. So I might pick 3 and 5. And because of symmetry, I know they're going to come out the same. So when I plug in 3, I get 1. That means 5 is also at 1. And then I might choose one more point, like 6. When I plug in 6, I get out 4. So I can plot a point at 6, 4. I can also reflect that one over that axis and make my parabola from there. Okay, let's look at B now. My vertex for this one is at -1 and -3. So -1, -3 on my graph. Then again, I'm going to pick some points around that. So maybe -2 and 0. When I plug those in, I get out -2. So that means that they're here. And if I pick one more point, like 1, I plug that in, I get a +1 out. So 1, 1 is a point, and then again, I can reflect that over the axis of symmetry and get a point on the other side as well to help me get a nice round parabola shape. Okay, let's try these next two. So these next two, still looking at my vertex. So in this case, I have a vertex at 5 and -6. So plotting that over here. And then again, picking some points around it. So maybe 4 and 6. When I plug in a 4, I get out -3, which means 6 is going to be the same. So plotting those. Looks like that. And then let's pick one more, maybe like 7. That's going to give me an output of 6. So we are way up here at +6. Again, reflecting that over. I get a skinny parabola that looks something like that. Okay, D, my vertex in this one is at -2, and I don't have a k value out there, so it's at 0. So -2, 0 is my vertex. Now this one has a negative out in front, so I want to think in my head, I know that it's opening downward. So when I pick values, I know that these ones around it should be lower than 0. So when I plug in -3, I would get out -1. Same thing would happen on the other side. So -3, -1, and the other side. And then if I plug in 0 as my next point, I would get -4 out. So 0 is at -4, and again, I can reflect that point over that axis of symmetry, get one on the other side, and I can see that my parabola opens downward like I expected. Okay, last two examples. This one has nothing with the x value, so that means my vertex is at 0, 5, since there's nothing attached to that x value. So 0, 5 would be up here. Again, it has that negative in front, so I know it's going to be opening downward. So let's pick some points around that, like -1 and +1. When I plug those in, I get out 4. So again, those points are lower, which is good because I know I want it to open downward. And then maybe I pick 2 next. Getting that, I would get a +1 out. So that would be down here at +1. Reflecting that over the axis of symmetry gives me my 5th point. I can plot my vertex from there. Okay, last example here. My vertex in this one is at 4 and 2. So plotting that on my graph, looks like that. This one has a 1/2 out in front, so I know it's going to open up and it's going to be a little bit wider. So I might pick a 3. And when I do that, I would get out 2.5. So not a lot bigger. So we can see that that growth is a lot smaller. So again, I could pick 5 here and know that it's at 2.5 also. If we pick 6, plugging that in, I get out a 4. So I know that at 6, it's up here at 4. And again, we can see that wider shape. It's not growing quite as fast as the other ones. All right, that is graphing from vertex form. We'll see you next time.